This video is going to be a PhD update. There's a handful of topics that I want to sort of get through. I want to talk through some like teaching philosophy and just what work assignment stuff has been as an end third year, beginning fourth year PhD mathematics student. I also want to talk about my coursework of what I've been taking lately and what I'm taking now since it's the start of a new year. And then also I want to talk about research stuff as well. Before I get into those three things, and if you want to just skip this little part and you want to get to the meat of the video and all that other stuff, it's chaptered out below. I took a break in August. I had some like very intense parasocial things happen, which was very jarring because I'm too small for that to be a problem currently. And then also I had finished up the experiments that I wanted to test over the summer for the channel. So I did my little like math structures thing of explainers in a very like base structural way, building up to through a section of material to see how that would go. And did some shorts for exercises that went along with that, and the results are in. That was a total bust for the channel. It was a first run at something like that, so I need to like go back, refactor it, and figure out what worked, what didn't, in a more deliberate way when I think about how I would want to structure something more episodic like that in the future. And then the other experiment that I did was I wanted to find a math video that came out that I could do sort of a response to where I went further in depth. And that turned out to be the best video, math-wise, that has ever gone up on my channel ever in a 24, 48-hour period. And that was my sort of like furthering of through Blue One Brown's video on the Moser circle problem, where I talk about hyperplane arrangements. I have a lot of ideas for other ones, but it's more of just like a time of the essence thing, and do I have enough time with everything else that I'm doing in order to make those? And the answer thus far has been no, which is unfortunate, but with just taking August to sort of like analyze how my summer experiments went, and then also think about how I want to create things moving into the school year, I have, I think, a better idea of how I would go about doing that in the future. So, yes, things a little bit weird last month, but there's a lot that's been happening in the background. I'm someone who, when I have a lot of things on my plate, I like to keep my head down and get through a lot of them and not come on here and talk about them, but I figured it would be a good time to talk about some of them. I haven't made one of these since back in the spring, so I'm going to start with just like teaching and work assignment and miscellaneous things, because that sort of gives an overall view of what I've been doing outside of like my coursework and research. And I guess this will naturally lead into research things, so that'll come up next. But with teaching and miscellaneous assignments, I've been doing a lot more calculus. I taught honors calculus 1 in the spring. I taught business calculus over the summer. And I graded for a differential equations class in the spring, and I'm grading for something that is also calculus flavored now. I can't really talk, I don't want to, well, I can talk about it, but I don't really want to, because I know that there's a small subset of math majors at my school who have also stumbled upon my content in the past, and I don't know if any of them are in that class, and graders are supposed to remain anonymous, so just to keep the anonymity for those, like, 20 to 40 people being vague, because class sizes vary, right? I'm not going to talk too much detail about work assignments that I'm in right now. But there's been a lot of calculus going on. And with that, when I took my like intro teaching math class way back my first year, I had a really great instructor, and she really focused on like, how do we do the things that we do, and why do we do things in the way that we do, and how to structure stuff in an intentional way. And she'd always talk about like relevant current pedagogy around teaching certain subject areas of math. And so being that calculus is a big thing that is taught most everywhere, I thought it would be a good idea to read some stuff about how teaching is done and all of that stuff, philosophies around teaching calculus. So I looked through some studies and all that stuff, and was reading a lot of educational or mathematics education papers in the spring and the summer as well, just to get a more of a feel for like why we do what we do, how what we do is, how well is that going, and just different like philosophies on how you should structure a math class with the pool of students that you're given. Because once you're teaching any subject at a collegiate level, a lot of times those students have already made a decision about mathematics, and it's not a positive one. And so there was a lot of stuff that I was like perusing through about how people go about teaching those classes as well. Because as someone who really does enjoy math, that experience of getting up there and teaching to a class that does not enjoy math at all can be very demoralizing. And you kind of like throw your entire self at it, because as someone who wants to finish a doctorate and wants to do research math and wants to work in academia, and also tries to do math comm, even though I'm not particularly good at it, just based on my video view count and all of that stuff. I'm kind of like in the subset of people who should be good at, or at least should be good advocates for math and popularization of the subject. And historically, a lot of people that fall into that group are also like really bad at popularizing mathematics. There's like a whole International Congress of Mathematics study or like thing that they talked about at a session in the 80s about it. It's very interesting. Anyway, so I've been thinking a lot about how I teach things. Part of that is just sort of confronting how I was taught a lot of math. A lot of my math was taught in a very structuralist way, where you write a definition on the board, you write a proposition on the board, you prove that proposition using the definition, and then you prove another thing, and you prove another thing, and you give some remarks here and there about the thing. That's how I sort of learn math. That's how I enjoy learning math. That's how I make a lot of my videos on here, is I try to sort of adhere to that structuralist model. But in a subject that is supposed to be like somewhat creative and is supposed to like focus on problem solving, I've kind of realized from all of that research that I need to sort of like tone down the structuralism just a little bit and give people time to think, because not everyone learns the way that I do, and that can be hard depending on what class I'm teaching. Like when I'm teaching like Cal 1 or Business Cal, there's a lot of material to get through in a very, very short amount of time. So there's not always time to like take 20 minutes to do problems as a group. But when you're in a 2-hour long class, sometimes it just makes sense to be like, I'm going to lecture for an hour and a half, and then for 20 minutes, I'm going to give you some problems to think about and chew on, and see where that goes, just to gauge what we got out of the hour and a half or less, depending. So like times may vary, right? But that's been just how like teaching stuff has been going, and just work assignment stuff. In terms of extracurricular math activities, I went to a conference. I went to my like first big international conference as a grad student. So I went to the 13th AIMS conference on blah, 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 blah. I'll put something up over here because the title was long. Dynamics was in the title. There was really only like one session on the type of dynamics that I do. And that was like a very good experience. I was supposed to go with a few other people from my institution, one who just finished their doctorate and another one who is a professor at my school. And like 5 hours before my red-eye flight out there, I got an email that was like, oh, hey, I won't be going. And then also when I got there, I like was looking around for the other person. And when I finally got to my session on the end of like the third day, I realized like, oh, they didn't come either. So I kind of just wandered around by myself at this conference for quite a bit, listening to a lot of mathematical physics talks, which is, I guess, fine. It felt more physicsy than math. And it was very jarring because I got to go to a lot of things where it's like, oh, there's a Casimir. I've heard about that in a class, but they're using a very, very particular example of one. Or they would talk about like Lie algebras and Lie brackets, and it would be like a very, very particular bracket where they can do all these computations. And someone talked about the Navier-Stokes equations, and there was some other stuff about how hyperplane arrangements work in data science, which was actually really cool. Hi Dan, if you're watching this, hello. I really enjoyed your talk. Dan is someone I lived with for like a few months in Budapest, and he watches my videos. He told me at the conference, so hello Dan. But I sort of like wandered through all of the mathematical physics and application talks to get to my session, which was on dynamics, where I was supposed to give a talk. And I did give that talk, and it went fairly well, because as a result of, well, at least it feels like as a result of working on MathCom and just how I give research talks and practicing math talks on here, so someone was like, oh, we should talk about a thing. And so I'm working with someone who's in Australia on a project, which is just, I still have no concept of how that happened. I mean, like I study things that they're interested in, as like for my dissertation, I'm working on things that they're interested in. And there's a question, and I guess this is the research part of the video. So we've slid into research through going to a conference. But I'm just like kind of totally like mind boggled, because you hear things like in this video where someone was like, I read a paper and I just emailed the guy, and they wanted to work on a thing and it was great. And you don't really think about that happening just willy-nilly. And that's kind of how it worked out, I guess. I knew of this person because they worked under my advisor, so I was just like waiting in the room for them to walk through the door to be like, hello, you worked with my advisor. Nice to meet you. But it wasn't until I gave my talk that it was like, oh, Nathan can calm math. This'll be good. So I'm working on a thing with someone in Australia right now, and it's kind of going well. At least it feels like it's going well. So I've proved some things. They've proved some things. It's going. So there's that, and then from my dissertation work, I'm working on some like multifractal analysis things. So like there's a pressure function, there's another pressure function, there's lots of pressure functions running around, and they're topological pressure functions or measure theoretic pressure functions or whatever type of pressure function you want to work with. And there's like connections between these pressure functions and dimensions of decomposed fractals, and what I mean by that is you take a fractal and you have a dynamical property and you cut up that fractal according to that dynamical property, and that gives you your multifractal decomposition, and you just want to know how each one of those pieces looks according to your dimension function of choice. A lot of the work that I think about currently is in a multifractal analysis lens. I'm like thinking about multifractal analysis in a more, I guess, concrete setting. I don't want to like totally shell out my topic before I know what I'm talking about, right? That's how this works. My dissertation has to be original, so got to keep some things in the back of the trunk until I'm ready to pull it out, right? So there's some more concrete things that I do multifractal analysis work with, and there are some less concrete things that I do multifractal analysis with currently. There's a lot of topology that comes up in what I do, which is, I mean, sure, it's a subfield of like dynamical systems and metric dynamics and or ergodic theory, and topological dynamics are very closely connected and blah, blah, blah. But I didn't expect that a lot of the proofs that I would work with are like, because the space is second countable and separable, yada, yada, yada. I didn't expect that to be a thing. Sorry, second category and separable, working with metric spaces. They're the separable and second countable, same thing. So research stuff has been pretty good, and it's been cool because before this I've been working more in like a undergraduate mentor capacity for research. So lots of checking proofs or giving ideas for how to approach proofs, or presenting additional information to help motivate some ideas from the undergrads. And there's a project associated with that. That is, I've kind of had to put on hold just because I don't have enough time to do it all, which is in terms of research. I do too much already on my website. So I have a Squarespace site, because who on this site does not, right? This is not sponsored, but I went ahead and like decided to sort of like compile some things on my Squarespace site about my research that I did with the undergrads. So there's actually like a whole page, and there's some animations and some graphs that you can see that I coded, to give you more of a visual representation of what that project was like. But that is very different than what I do with dissertation and Australia Man. So yes, the last thing I really want to talk about is coursework things. So I've already kind of, well, I sort of talked about coursework stuff in the video that I did about extending 3 blue 1 brown's Moser circle problem update video, right? So I talked about hyperplane arrangements. I had a whole class on hyperplane arrangements in the spring, and it was very, very cool. It was taught by someone who does lots of different things in math, ranging from algebra to combinatorics to algebraic topology and homology theory and all of those things. And aside from the mathematical content, because a lot of that mathematical content I won't need for what I do, at least it won't go that deep. I won't, it's like, there's the whole like bridges between mathematical fields, and sometimes you have to go very deep into the weeds in order to find any connections. But my work currently doesn't try to do that. So I probably won't use a lot of the math that I learned in that class. And whenever you take classes that you're not super interested in, it's always nice to note that if teaching is going to be a part of what you do later on, or some learning in general, it's really nice to just pay attention to how someone teaches things. So it was really cool just to see how they went about teaching stuff. And this was true for all of my classes. It was cool to just, if I wasn't getting academic, or I wasn't getting relevant mathematical information out of a particular class, I would still be taking notes and whatnot. But I would just pay special attention to like, how are they structuring their class? What types of things are they talking about and putting more emphasis on, and how do they just like lead a course? My other classes were not as exciting to me, even though one of them was relevant to what I do. So I took a class in, I want to say, automorphic forms. I feel like that's what the title of the class was called. I've taken like 3 of these classes at this point. They've all been different. One of them was just the end of my complex analysis graduate level course, was automorphic forms stuff, or modular forms stuff. And then I've had another semester of modular forms things, and then, or automorph, I don't know if I think it was called automorphic forms, but we just did modular forms things. Anyway, it's not super important. I'll put some pretty pictures over there. But I had another course in modular / automorphic forms that was this time taught by an algebraist instead of an analyst. Was taught by someone who is more on the algebra flavored side of number theory as opposed to the analysis side of number theory. I know a lot of people who are doing research in that area at my institution, and so it was cool to see what they work on in like at the lowest possible level. But it kind of was what it was. And the class that was relevant to what I do was functional analysis. So finally took the class. did not have a particularly good time taking the class for a handful of reasons. But it was helpful because I do run into like functional analysis type things and operators and duals of operators and weak start topologies and all of these things a lot when I'm doing my research. So it was good to have more of like a structured introduction to those things as opposed to just reading something and going, huh, I guess that's an object that I don't know that exists somewhere out in the math forest in a tree by itself. I don't know where that came from. Was it helpful content-wise? Sure. Was it a nice class overall? I don't know. I don't really know. But I think in hindsight, I appreciate it more than I did at the time that I was in it. Right? So summer, nothing really happens. I run around with money anxiety because I am poor, because I don't make really any money during the summer. And I taught a class for the school in order to remedy that. And then I also like sort of did some research things in between there and tried to keep up with that while trying to figure out how to pay rent. C'est la vie. And now the fall has come and I'm taking some more classes. So I've officially started my dissertation hours, which is exciting because I've been doing things that are associated to working towards doing the research that will go into my dissertation for quite a while now. But now I like have it on my transcript of like, oh, you're working on the thing, which is very cool. And then I'm taking a class in like modern topics in linear algebra, which is, I don't have much to say about that one yet. Just because it's run very, very differently than any other class that I've ever had. It's more like discussion based, which is, I think it works. I think it works for a PhD level math class. Sure. We all know some things about math. We are all assumedly have taken a qual or two. Like we can board out math together and talk about it. That seems fine. That sounds great. Why aren't more classes like that? But I don't know, like, I've only been it for like a week and a half or 2 weeks now. So I don't really know if it is like going well, I guess. I've enjoyed it thus far, which is kind of odd because I am not a fan of linear algebra. All of the matrices that I think about are omega by omega, and they have entries of zeros or ones, and there's no algebra you can do with them, essentially. So I don't think about matrices in like the finite dimensional sense very often. And also, that's the wrong way to think about an infinite matrix, what I just said. You shouldn't think about it that way. So yeah, that class is a trip. And then I'm taking a topics class in my area, which is topological dynamics and ergodic theory. And that's the same class that I took. It's essentially the same class that I took like my second year. They let us do this just because, like, especially if your advisor is the one who teaches a class in your area, it's like good for you to sit in on things and see it again because repetition helps, especially with the basics and something that you're not familiar with. It's also the only class in dynamics that's really been offered at my school while I've been there at my level. So going back through and seeing it again has been, it's been helpful. It's a weird experience to like be in the back of the classroom and watch people talk about things and then have like an immediate counterexample in your brain of why what's happening doesn't necessarily work out, or like to practice that sort of like knowledge retrieval of, oh, I should know that there is an infinite minimal subshift and things like that. But sometimes finding holes in those arguments is much more difficult than it would appear. So it's sort of a different cadence and information extraction to it this time. So like for that last thing, since my advisor teaches that class, he's asked me to like research some things and present them after the holiday, because this video should come out on Labor Day, but will that happen? I think that's basically it. This was a long one. This is about 30 minutes of me just talking here, recording, so we'll see how much of this I chop out and how well this looked. Hopefully this was not unbearable. I did forget to turn off my fan, so maybe the audio is terrible. I apologize for that, but I need to just really figure out how I'm going to use this thing, and this video was the place to do it. So anyway, as always, I am Nathan. This one was Chocolates. It was just a little update about PhD things, and I will see you. Well, okay, before that, like, you know, you can subscribe for more mathematics things that I do on this channel, or if you want to hear me update you on PhD things in the future, you can give me some comments down below. Otherwise, that's basically it. I will see you next time.